Dear students, last session we have discussed about the two graphs related to the motion. Now we have to derive the equations for the motion. There are three equations. In these three equations relating the quantities initial velocity, final velocity, acceleration, time, distance or displacement. So we have to make the derivation means we have to make the equations. Our topic is equations of motion by graphical method. So our aim is to derive these equations. In maths we have studied so many equations, but here what we are doing is we will make this equation from this graph. So our first one is equation for velocity time relation. See, these are the three equations of motion. We will derive one by one. This is the first equation of motion. V equal to u plus at. I hope all of you know the letters. V means final velocity, u initial velocity, a acceleration and t time. This is the second equation of motion, that is s equal to ut plus half at square. S means distance or displacement, u initial velocity time, then acceleration and time. So we can start our derivation. You will study more derivation in higher classes. This is just an introduction for derivations in physics that will continue from 11th standard. So we will get an idea how to derive the equations in physics. First one, equation for velocity time relation. Every derivation will have an introduction part, then a calculation part, and the final result. Okay, so this is a method. So we can start our introduction part. Consider velocity time graph of an object moving with uniform acceleration as shown in figure. So we have explained the graph. Then we have to mention the initial velocity, final velocity, the time and all. Let u be the initial velocity of the object, and after time t, the velocity increases to v. That means the final velocity is v. So how will you explain the second one? Let u be the initial velocity of the object, and it increases after the time t and reaches velocity v. So this is the initial velocity. U is the initial velocity and v is the final velocity. And we have mentioned the time. So we have completed our introduction part. I will repeat. Consider the velocity time graph of an object moving with uniform acceleration as shown in figure. So we will draw the figure first, then we will start writing the introduction. Then let u be the initial velocity of the object, and it start increasing and reaches v in time t. So we have mentioned the initial velocity. Initial velocity means starting velocity, and final velocity is represented by v, and time is also mentioned. It is represented by t. So we have mentioned all the things. In the first part, we have to derive the equation for velocity time relation. Here we are relating velocity with time. See, we have studied that acceleration. Actually, we have to derive this equation. This is the first equation. We are going to derive the first equation. We know that acceleration is represented by a. Acceleration is equal to, what is the equation to find the acceleration? Change in velocity by time. When you study the definition of acceleration, you have studied the equation. Acceleration A equal to change in velocity divided by time. Now we can move to the graph. Here v is the final velocity and u is the initial velocity. So what will be change in velocity up to here? That is v. Up to here v. Then what is change in velocity? The velocity starts changing from u to v. So this is our part. This value will give the change in velocity. So I am writing in letters a equal to, what is change in velocity? This can be represented by bd. bd divided by, then what is time? Time equal to OC. Now we can replace this BD. How will we calculate BD? BD can be written as BC minus CD. Isn't it? If you want to find this one, BD, how will we calculate from the graph? We will take BC, then we will minus CD. So we can replace BD equal to BC minus CD divided by OC will be equal to time t. Then now substitute the values. What is BC? BC equal to V, that is final velocity, minus what is CD, that is equal to CD is equal to U, then V minus U by T. Now we got the equation A equal to V minus U by T, and just rearrange the equation. We can take A equal to V minus U divided by T. Just take this T to this side, then here T is in division side, then when it change to this side it will become multiplication. A T equal to V minus U, isn't it? T can be taken to this side, so A into T equal to V minus U. And just rearrange the equation, we have to get final velocity equal to V equal to. So I am taking this V equal to, we have to take this minus U from this side to other side. So what is the equation? V minus V equal to minus U. When we take minus U from one side to other side, it will become positive. So U plus, here is only positive value, U plus AT. So this is the first equation of motion. If we know the initial velocity, acceleration and given time, then you can calculate the final velocity of the object. In some cases, they will give the final velocity, initial velocity and time. Anyway, they will give three quantities, then you can find the fourth quantity. So we have concluded the first equation. Now put it in a box and name it as equation 1. Now we can move to the second part, the derivation of the equation for position time relation. In order to find that, we have studied that area under the velocity time graph gives the distance traveled by the body. So we have to find the distance traveled by the body. So the distance traveled by the body, the distance traveled is represented by S. What you have studied? Area under the velocity time graph is the distance traveled by the body. So distance traveled by the body S equal to area under which graph? Velocity time graph. So here, if you want to find the distance traveled by the body between A and B, you have to find the area of this graph. See, the procedure is same for the first, second and third equations, but we will, in the first part, we will combine the areas of rectangle plus triangle, and for the third equation, we will take this as a rhombus. So, for here we can write area of, what is the shape? OABC. OABC. This area of OABC can be replaced. We can divide this area into two parts. Rectangle, area of rectangle OABC and area of triangle ABD. So we can write area of rectangle. What's the name? ADCO plus area of triangle ABD. Now substitute the equations for this. How to find the area of a rectangle? That will be equal to length into breadth, plus area of triangle half into BH. Then length, here length can be represented as OC into height can be represented as BC plus half into, here what will be the base? Base will be equal to AD into what will be height? This will be height of the triangle B. Now substitute the values. What is OC? OC equal to OC, that gives the time, T into what is DC? DC equal to U plus half into AD again T, then BD. What is BD? We get BD like BD means BC minus DC. We have already found for the first one B minus U. If you want, you can draw that in the figure itself. Then you can represent B minus U. I'm just replacing these equations. S equal to UT plus half t into v minus u. T into. See, we have to substitute for v minus u from the first equation. So in the side you can write substitute v minus u. Just rearrange this equation in order to get the v minus u. Then in the right side you can write v equal to u plus a. That is the first equation. I am taking this. We need v minus u. Here we have to replace for v minus u. So you can take this u to this side. Then what you get v minus u equal to a into t. Isn't it? So substitute that v minus u for here. So what we get instead of v minus u, we have to write a. Now just compare the equation s equal to ut plus half into a into 2 t's are like e into t, that's equal to t square, half a t square. So this is the second equation of motion. Equation 2, in this equation 2. So we have derived the second equation. Now we can derive the third equation. This procedure for deriving the second and third equation are same. Up to here that will be same. The distance traveled s equal to here. Instead of position time, we have to write the position velocity relation. And third. See, this will be same. The distance traveled equal to area under the velocity time graph. Here, area. This is the area. In maths, you have studied this shape is called trapezium. Isn't it? A trapezium has a pair of parallel lines. Here, this is the basic structure of a trapezium. One lengthy part and another two parts under, two lines under, and it is represented by A and B. The lengthy part is represented by A, and next parallel line is represented by B, and height is the perpendicular drawn between the two parallel lines. Here, I am just twisting that trapezium into this side. So I am just twisting, then you will get this structure. So our figure is like this, isn't it? So here, this will be the lengthy part. These two, BC and AO will be the parallel, a pair of parallel lines, and these are unparalleled lines, that is AB and OC. So here, we can write area under velocity diagram as area of trapezium. What's the name of trapezium? OABC. OABC. Isn't it? Now we have to write the equation to find the area of trapezium. Half h into n plus b into h. A and B are parallel lines, and h is the perpendicular distance between parallel lines. Now here, just observe the parallel lines. This is the lengthy part A. BC is the lengthy part, so it can be represented by A. And small letter B can be represented by the shortest part, this one, OA. So I am just replacing with the that is half into BC plus OA. And what is height here? Actually, this is twisted trapezium. So height will be, you can write height as AD or OC. According to your convenience, you can write. Then I am taking AD. Now substitute the letters symbol for that. Half into BC. What is BC? V. Isn't it? BC. This much distance is equal to V, and OA is equal to U. V plus U into what is AD? AD is equal to OC, that's equal to T. Okay, so we got S equal to half into V plus U into T. In this equation, we have to substitute for T. In the second equation, we have substituted for that V minus U. Here, no V minus U. We are not substituting for velocity, we are substituting for time. Just check the heading position velocity relation. So we do not do substitute for velocity, we have to substitute for time only. So first equation is V equal to U plus AT. Rearrange this equation in order to get T. So I am writing AT equal to V minus U, isn't it? Then T equal to V minus U divided by A. Substitute this value for this relation for T. So what you get? Half into V plus U into V minus U divided by A. I'm just rewriting the equation again. Half into b plus u into b minus u divided by a, isn't it? Then what's the relation to find this one? A plus b into a minus b. A plus b into a minus b is equal to a square minus b square. Similarly here, b plus u minus b minus u will be can be replaced by b square minus u square. B square minus u square divided by 1 by 2a. Here 1 into this value, that is b square minus u square. 2 into a can be represented by 2a. Now we can take, I'm just writing here, s equal to b square minus u square divided by 2a. I'm taking this 2a to this side. Then s into 2a, that is 2a s equal to, I'm taking this 2a to this side. Then it will be multiplication. 2a into s, or multiplication is a commutative. So it doesn't matter if you multiply a with b or b with s, you will get the same value. So I just written 2as is equal to b square minus u square. So we got the third equation also. This is how the way you have to run the three equations of motion.